let's take a look at a fake carbon dioxide detector from eBay. These are all over eBay. This particular one displays temperature, humidity, and the carbon dioxide level in the vicinity. I'm not sure why people necessarily want to know this. I can think of more useful things to measure, but unless you're living in a hermetically sealed building, the level of carbon dioxide isn't necessarily going to go too high. However, let's check the accuracy of this when exposed to pure carbon dioxide. So for that, I have my soda stream, which has a carbon dioxide port in the back that puts the carbon dioxide into the drink. I'm going to spray it directly into the sensor I can see in here, and we'll see how it fares. Loud noise coming up. That's quite a lot of carbon dioxide. The reading is not changing significantly. It's certainly not enough for the amount that I've just bombarded into it. However, it is reading something. Watch this. If I squirt some isopropyl alcohol into my hand, just to get it vaporized, and rub it together to create a nice bit of that vapor, and I hold it, there's going to be a loud alarm noise, it goes off the scale. So this thing is detecting alcohol. And it makes me wonder, have they just put in basically a breathalyzer sensor module? And I tested this with various chemicals. This stuff is still all over the hand. It's not going to return for a while to normal levels. I tested it with methylated spirits. It triggers it. I tested with the isopropyl, as I've just done. It triggered it. If you have a wee sip of wine or beer and you blow into it, it triggers it. I was going to have a glass of wine before making this video, and I thought that would not be a good idea because my breath would have actually been registering in this. I looked up online and I found there are alcohol sensors, MQ3 alcohol sensor, but it also apparently detects petroleum distillates. And I tried it with lighter fluid, no reaction. I tried it with white spirit, no reaction. I tried it with butane gas, no reaction. It just seems to be alcohols. The one slight variation by using a puff of this device for inhaling nicotine, it did actually register that. I don't know if it was just I'm not sure if it was the propylene glycol, the glycerin, the NiCotine, or the chemical flavourings that were included in it. They don't tend to declare all the flavourings. They just say flavouring. Anyway, let's open this up. And we'll see what's inside. I should mention it's rechargeable by USB-C port. It's got the on-off button. It's notable that it may be designed for an actual carbon dioxide sensor because when I put it outside, it gradually went down in the level and stuck at 400 ppm. And that is the ambient outdoor level. So I wonder if it self-calibrates if you place it outdoors by going down to 400 ppm, well, the lowest it goes down to, if it goes down lower than that, it just recalibrates that as the base 400 ppm level. Typically, outdoor air is about 78% nitrogen, 21% oxygen, and between 0.03 and 0.04% carbon dioxide. A bit higher indoors because, of course, we're breathing all that oxygen and exhaling carbon dioxide. There's also ozone and argon and other exciting stuff in the air, but they're not relevant here. What I am seeing here, though, is a very nice, oh, that's it open. I am seeing quite a nice project case. If this turns out to be programmable in some way, reprogrammable, then it's possible. You've got a nice colour display, you've got the battery charging circuit, there's a little sensor there. Not being able to identify that. I've had a wee look before, but we'll take a closer look at this. I'll get the circuit board out and we can have a look. There's the sounder. There's a little switching regulator supply. I shall monitor some voltages off that. I'll do that now. I shall get the data and we'll take a look at it and see what we can find. One moment, please. And resume with the reverse engineering. I have got a glass of wine here. This is purely for test purposes so I can blow in the sensor and annoy it with my alcoholism. One moment. Oh yeah, that set off the party alarm. So there we have it. It's a party alarm. That's it. I should put it out the way because otherwise it's going to keep going off every time I breathe roughly in its direction. Let's take a look at the circuitry. I shall zoom down and we'll do a block analysis of this instead of doing it to every component because there's quite a lot in this. Noting the microcontroller here has been lasered. They've removed the logo off it, but they've left a little sort of S shape in there. Not sure what that is. But given that this is so, shall we say, modular, it's got data input from this module, it's got analog input from this module, it's switching the output to the beeper, and it's got an input from the charge circuitry. I would say that this is most likely Arduino-ish, if you know what I mean. It's very modular, but then it isn't everything these days. So the power supply for the charger, USB charger, comes in here. It will not be recognized by modern fancy USB chargers. If it's USB-C, if it doesn't charge, plug it into a dumb charger. They've not put the resistors in. The two meager resistors that would have made it compatible with other chargers and told it. It's not even a high current. It seems to charge about 350 milliamps because that resistor there is about 2.6K, the one that sets the current on the LT87 charge control. There's something really annoying about this. It's got a 1 amp hour lithium cell that connects to here. It could have connected between this positive connection and this one if they'd put this chip in, because this is a protection chip for the cell with its little filter capacitor and resistor, but they didn't include them to save a wee penny and it's on the battery instead. No, it's not. There's no protection. So it must be monitoring the voltage, maybe with the... Is it monitoring it with the microcontroller? Who knows? If they were trying to save money, they've really screwed up because this bit here is a boost circuit for 5 volts from the battery supply. And I haven't found anything it's used in. It goes to the output, the serial programming port here, presumably. It goes to this matching serial program port and this infrared module port. I translated that. But it's not actually used by any of the circuitry that I can see on here. So they could have saved money by just not including all this circuitry here. Accountant, eat your heart out. Other things. It's got the module here. This is quite interesting. But that is the gas sensor module with 3 connections, 3.3 volts, 0 volts, and an analog signal back. We'll look at that in more detail. And we've got a DHT11, which is 3.3 volt, 0 volt, and data, and gives you temperature and humidity. It's a very generic module, notorious for being not terribly accurate, no facility for compensation included. Things that are worthy of note that are really interesting. There's an A1SHB transistor here which switches the circuit on, and it switches on the 3.3 volt regulator. It connects it to the battery. It can be turned on either by the processor using a transistor to pull the gate to the 0 volt rail, or via this switch over here which can pull it to the 0 volt rail via a 1K resistor. And basically speaking, you press the button, it wakes everything up, and then once the processor is booted, it basically sends a signal transistor that latches it on. And when you press the button, it can sense the buttons being pressed, and it will then effectively turn the MOSFET, the transistor off, and the MOSFET drops out if it detects, that you've released the button. This little module here, let's zoom up on that. Enhance. There is the enhanced image. Let's zoom in on it. Things worthy of note. It seems to be using a standard tin oxide style sensor, which has a heater. In this case, it's got a ridiculously high value of 10K, which I find hard to believe, but it's a thin film technology version. We'll cover that in a moment. And that has a resistive sensing element, the tin oxide element, in series with a 10K resistor, and that provides the analog output. For stable readings, and this is a bit odd, they've got 3.3 volt providing the heater supply, but also going to this customizable regulator, the 65K5, is that right? And it puts out 1.76 volts because you can choose the voltage. The best thing about that regulator by far is the name of the manufacturer, which is Shenzhen Fine Mad Electronics Group. That's a great name. Fine Mad Electronics Group, that's great. But it's programmed between 1.5 to 5 volts in 0.1 volt increments. So I'm guessing that this is supposed to be 1.8 or 1.7. It depends the tolerance. They kind of didn't need it. I shall show you why. Let me bring in the schematic and we can talk about that. Can you tell the wine has been partaken at a high enough level to do the scientific tests, but also far too high a level for sensible electronic discussion? This is a good thing. There is also a bit of a monolithic F-up in this circuit, but not to worry, it's fine. Here's the USB-C charging port. It goes to the LTH7 and the charge pin. There is also an option for a TP4056 on the board, but the charge pin goes over to the microcontroller. That's the F-up because it's leaking current. There is a programming resistor, I think that's leaking current, 2.6K, which sets about 350 milliamps. Certainly that's what I measured it at. The output of that goes to the lithium cell with no protection whatsoever. And then it goes to the MOSFET. And the MOSFET effectively is being pulled off. Yes, that's not the correct terminology. It's being pulled off. I like it. With this resistor, it's being held off on its gate. It's an A1SHB, which is a P-channel MOSFET. And the ways of turning it on are for this transistor to be turned on. I just thought there's something wrong here, but that's okay. This button must also have another. That's why it's got the 1K resistor. It's also got another resistor over to the processor. Slight error in this schematic, but that's okay. But you'll get the gist, and it's an interesting thing to note. When you push the button, it bypasses the MOSFET with the resistor. What that does is it allows this, bypasses the transistor with the button, and it turns this MOSFET on. The MOSFET enables the 3.3 volts. The processor boots up, and when it's ready, after a slight time delay, it turns this transistor on and it locks the thing on. If you release the button before it's locked on, it will just drop back out again. So once it's ready, once it's booted up, it locks, it bypasses the button. But it must still be sensing the button because that's how it's turned off. So I've got that slightly wrong. There's obviously, the button is maybe pulling to the ground, plus also, that might, oh, you know what? No, that wouldn't work. Anyway, there's something else going on here, that if the button is pulled down, there might be a resistor there and then another resistor from the 3.3 volt rail there. That would work. Anyway, carrying on, the microcontroller can control the peeper, the bit that detects my alcoholic breath, allowing me to breathe gently in its direction. Oh no, party alarm. But also rather disastrously, it controls the backlight. I'm not sure what the current of the backlight is. I was looking for the transistor for the backlight. It's the LEDs for the backlight. The resistor was there, but I couldn't measure it. It's so low. It's pretty much a link going straight to the microcontroller. 3.3 volt, it's going to be close to the voltage of the LEDs anyway, but the microcontroller is working hard on that pin. The sensor module is connected to 3.3 volt rail, and the 0 volt rail, I'll just mark the 0 volt, there we go. And it sends its analog signal back. And this is the DHT11, is that what it is? I can never remember. DTH11? It's the DHT11, indeed, the horribly inaccurate but cheap humidity and temperature sensor. And it's got the 3.3 volt, 0 volt, and it sends data back. I'm thinking do we know? It just makes sense. The display. Oh, actually, you know what? This might have it clearly has, wherever this is, it's got an LCD display driver. These pins here, let me show you the module. Try not to breathe in it too hard. These pins here, it'll be power and data to agree. Parallel data? Is it driving it directly? Maybe it is an LCD driver. But these pins here go straight through and onto the LCD panel. That means it's not smart. That chip is an LCD driver in it. And there's the LED backlight at this end. Interesting. So what is that chip then? Now that has cast doubt into my mind about whether it is an Arduino-ish thing. Oh, there's something else worth noting. On the circuit board here, you've got a little connector position here and a connector position here, and it's connected through to this little sensor position, whatever it is. You can basically, if you leave the circuit board in position, then you don't need the connector. But if you add the connector, then you can snap that circuit board out and mount it remotely. It's a sensor of some kind. I don't know what it is. Maybe it's an extension of the infrared sensor for remote controlling it. So I haven't a clue why you'd want to do that. Let's talk about the sensor. The little circuit board of the sensor has the 3.3 volts coming on, and it's got the heater. I'll show you why it's got the heater in a moment. It's 10k, that would pass 0.3 milliamps and it would be 1 milliwatt, which is extraordinarily low. There's the 1.6 volt regulator. Now, in these sensors, you have the tin oxide coating, which usually, which changes its resistance. The more impurities there are, the lower its resistance goes because it's blocking oxygen. I'll show you that in the next page. I'll have to draw it out. And that forms a potential divider of this 10k resistor. But this is not connected to the heater in any way, which is used these things. So they could have used the sensor down here, and they could have used a resistor of their chosen value to tune that up there, and they could have actually used that as the output, and they wouldn't have needed the voltage regulator because they've already got a fairly stable 3.3 volt supply. I don't know why they did that. Did they just not know what they were doing or something? I'm not sure. Maybe there's a reason they didn't do that. Anyway, let me show you tin oxide sensors because they are interesting in their own right. I'm assuming it is tin oxide. It kind of fits the description of tin oxide. Have you seen those little sensors that have the domed top? And it's a mesh top, and the reason it's a mesh top is because it's designed to prevent explosions because there is a little heater inside, and it's got 6 pins sticking out the bottom, usually in a sort of 1, 2, 3, 4, 5, 6 sort of pattern round it in a circle. What's actually inside those is a pin here and a pin here with a heater. I'll just draw it as a zigzaggy line here. And round that is a aluminium ceramic tube. Is that right? Aluminium oxide tube. It's a ceramic tube, and it is coated with tin oxide. Then you've got the other 2 pins which are linked like that. They're just basic for support, and they connect to that. Now, this is not my area of expertise. If you can contribute some to this, by all means let me know, because I don't know how the different sensors detect different gases. But the classic thing is there's a layer of tin oxide in this, and when it's heated up, its resistance is affected by the availability of oxygen. So normally oxygen would fill in all the sort of gaps on this tin oxide, and it goes high resistance. As stuff like smoke, carbon monoxide, carbon dioxide, if you get the correct sensor, alcohols, whatever it's tuned for, and they may dope the tin oxide to actually change its characteristics. What that does is it actually takes the oxygen away, and it blocks the oxygen from getting to it, and that actually lowers the resistance. It allows the electrical current to flow along the surface of this material, and what you end up basically is with a gas-sensitive resistor. And normally the heater passes a fair amount of current through that, but because these little chips use the thin film technology, they have the heat, they have a thin insulator on top, and then they've got the tin oxide with the wires going onto the top of that. And because it's all done super small and thin, they can have a much higher value of resistor for the heat because it doesn't have to get so hot. I'm not sure about the science of this because everything I look at, like ozone, tin oxide, carbon dioxide, tin oxide, it must be different metals. The tin oxide seems particularly suitable to this. It's a very inert, it's a very innocuous material. But they must be doping it in some way. They must be treating it in some way to make it very gas selective. Very interesting. But that is it. That is the gas sensor. There was something in my mind there about the tin oxide sensors. I don't really know what it was. I've just completely forgotten what it was there. But it's nice that it just acts as a resistor because literally that resistor there, you just put it in a potential divider. And it is isolated electrically from the heater. That's actually the heater I've shown it connected to. Let's show it connect to the right bit. And that will form a very simple resistor divider. And I have to say that when I blew on this, the resistance changed from, let me see, I made a note of this. I made a note of that somewhere. The resistance changed so that the voltage on the divider output went from about, hold on, I'm just going to find that. One moment, please. Here's a better idea. I'll demonstrate it. Here is wine. I shall put a probe on and I shall measure between the ground and the analog output of that, and it shows a voltage of about 1.5 volts. Say 1.5 because I'm breathing on it and I've been drinking wine. Right, watch what happens when I really drink wine. I'll spill some of this in the wine in my mouth and blow in it. See the voltage shoot up? That's how significant the change is when the ethanol in the wine hits it from my breath. Kind of interesting. That's a huge change, isn't it? It literally went from like about 1.5 to about 2.5 volts, or whatever that was. So that's kind of interesting. So there we have it. This thing's going to go off again. It's going to keep going off, isn't it? Because I'm breathing on it. Oh, there's a switch. So, interesting thing. It makes me wonder, this looks like a standard case. It's got the port here. It's designed for gas sensing. Did they just go to this company and say, we want the cheapest one you can give us? And they said, well, you know, if you want carbon dioxide, it's going to be quite expensive because the carbon dioxide sensors are quite expensive. And they maybe said, what's the cheapest sensor you got? And they said, well, obviously it's the breathalyzer alcohol sensor, but that's not any good. And they said, well, just put CO2 on it anyway. No, we can't do that. Do it or we won't buy your product. Okay, here it is. Your cheapest carbon dioxide sensor that is actually a party sensor that can detect wine at a considerable distance. Oh, I'm going to blow in it again. Oh, off the scale. Just blowing at it. Isn't that great? There must be a use for this. But it's nice that they actually use a real sensor. What comes to mind is ghost detectors. You know how the ghost detecting industry tends to rely on random elements and things that react to the environment. That's what this is doing. But it's using the cheapest sense they could get to react to the environment so it changes notably as if it is monitoring CO2. And how is your average Karen going to realise that they're not actually monitoring the CO2? Another nice thing about this is the case, because this stick-on bezel on the front has no text in it at all. It's basically screen printed black, and then they've put the adhesive layer on it so it just peel off and stick on. All the customization of this product is done on the LCD display, a full color LCD display, which is quite nice. Let me just check, is it full color in the sense that, hold on, or is it just segmented out? Oh, I'm not seeing, hold on one moment, I'm just going to check this. I am not seeing pixels. I thought this was a generic LCD display, RGB, and you know the sections, they were just displaying graphics on it. It actually looks as though it is perhaps a dedicated LCD display designed for the application with 7 segment sections. That's unexpected. I thought they were going to use a generic LCD display. That spoils the concept of reusing this with your own project if you could decipher what processor it was and actually reprogram it, because it does appear to be designed for a specific function. Oh, that's kind of ruined things a bit. But having said that, it was worth taking apart, worth getting just the fun of it, the fact it is so utterly fake. And yes, it's detecting my wine again. That's what happens. But there we go. That is your fake detector. Something else worth noting, some of them are so fake, they don't even have a sensor. They just fake the values. Like those health watches that fake your heart rate, your blood oxygen level, and everything else. They just fake everything. There's a lot of fakery on eBay. This is not a surprise. But things in its favour, it's quite an interesting design, and it does have a decent battery to give you fake readings for a good length of time. And I like the fact that when you put it outdoors, it does seem to actually try to compensate down to the ambient 400 parts per million of what it would perceive as the lowest level you're going to get of carbon dioxide. And then it just maybe, I don't know if it's got flash memory in it, maybe it will default that as the base level. Every time it goes lower than 400 parts per million, it sets that as the new defined standard that everything else is based off, even if it doesn't have the carbon dioxide sensor.